Welcome back friends, and in the last lecture we had kind of wrapped up our discussions on second level packaging, and primarily that was to do with number one, that was primarily to do with the interconnections from the package, which is a substrate, to the motherboard and the connections thereof, right. So, as part of that we had talked about motherboard fabrication, and finally, we also talked about the assembly of components on the motherboard, the different steps involved and so on. Okay. Today what we are going to talk about, the topic of discussion today is third level packaging. Okay. Sometimes third and fourth levels are, or you can even say third and fourth level packaging if you want to call it, because here is where what you call 3, what you call 4, that gets a little hazy. So, many people say that okay, I have this motherboard, and apart from the components and packages that are directly bonded on the motherboard, anything else that is connected onto the motherboard is third level packaging, okay, which is removable. And then finally, when it goes to the overall enclosure, and which is finally what is sold in the market with the protective final housing around it, that is fourth level packaging. Okay. And then there are some people who say no, both are they are not very different from each other. So, anyway, so what I am trying to say is third and fourth levels, the definitions or the agreements on these become a little hazy, but nevertheless we know what steps are involved, whether you call it number 3, level 4, that is not so important. All right. So, today we are going to talk about both, and this is going to be one lecture. This is the concept that we will cover today is about system packaging. So, how do you now convert whatever we had, the piece of silicon, the package, and now which is connected onto the motherboard, into a final system? What does it entail? Okay. And as part of system packaging is where many things come into being. These are probably not very intricate from the point of electrical design or even manufacturing, but nevertheless very, very important in order to give the final user experience and of the functional device. All right. So, we will start with motherboards and daughter cards, then we are going to talk about connectors, and finally end with enclosures. All right. So, let us move on. The first one is motherboard and daughter cards. So, what is a motherboard and what is a daughter board or daughter card or expansion cards? So, motherboard is the largest circuit board, the major circuit board that is there in a system, which also typically is also the largest component inside any system. Okay. If you look at, for example, a laptop computer, and most of it is a motherboard. If you go inside, if you open the box, the bottom unit, it is a motherboard, which is the largest one. Even a desktop also has a large motherboard. If it is a tower, it is vertically aligned and so on. All right. So, that houses the components and smaller boards and expansion cards. Okay. And then onto the motherboard, of course, you have components that are attached, as we saw in the last in our second level packaging, but you also have these provisions for connecting additional smaller circuit cards. Okay. So, those are often called the daughter boards or daughter cards, expansion cards, and so on. So, these are smaller circuit card assemblies with special functionalities, and then what happens is these are connected, kind of, you can even say inserted or plugged into the motherboard through their respective connectors. All right. So, typically there is a socket and there is a connector, they just go and mate, and that is how the connections are made. So, one of the prime examples is memory. All right. These days we also have, for smaller ones, we have onboard memory, but otherwise, especially for desktops, servers, the memory is upgradable. We all, especially in desktops, we say upgradable memory. Even for laptops, I do not know finally how many people end up upgrading laptop memory. I did it once, by the way, but even though many people do, they insist on that. It is just probably the sense that I have that ability or the capability or the flexibility to upgrade my memory if required. Most people do not end up doing that, but it is possible. So, what you see at the bottom is the memory card. This is of a desktop, and See, many a times you see on this memory card you have these connectors. By the way, this we saw these as part of the motherboard fabrication process, and this connector goes into a socket like this one over here. If you look at this motherboard on top, which is from a laptop, we have seen this picture before, you see this socket for a memory card, and this is where the memory card is inserted, okay? And that is how the mating will be done. So, memory cards is not the only thing, Ethernet cards, even these days the basic this flash memory cards, okay. These are all kind of small circuit boards or with devices inside, okay. So, PCM CIM not very common these days, but that used to be common at one point of time. I have used that. It was pretty prevalent even 10 years back. Over the last few years, we do not see much of those. So, these are examples of daughter cards or expansion cards. And then, so this also calls for connectors, because these are connectors. You need this connector and the socket, the female and male parts for this mating. And what are these connectors? What connectors are supposed to do? Well, we know, but we will see more formally in one of the subsequent slides. Okay. So, typical daughter cards, some examples. You see memory cards on the left. I think these are all well known to you. I do not need to explain, right? Especially, but except maybe the bottom one, which is a typical PCM CIA. Okay. But on the right hand side, you do see Ethernet card, you see wireless network card. We know these, right? These are there in our desktops, even laptops. Laptop sometimes it is inbuilt, it is not different, but in desktops we see this. This is a separate card, small one. Okay. But what do we see here? We see this Ethernet card, both this one as well as the wireless network card has a small connector which is going to plug into a socket on the major motherboard, the main circuit board, which is the motherboard. Okay. So, these daughter cards, as I said before, they have their own functionalities. Ethernet card, we know what they are supposed to do. Wireless network card, we know what they are supposed to do. And you have components accomplishing those functions with those functionalities that are bonded on these smaller circuit cards. Okay. Many of them are, as you can see, these are peripheral packages. If you can, I do not know how large it is on your screens, you can see some of these can be even ball grid array packages, direct bonded. Okay. Probably in this socket, in these smaller circuit cards, it is not very common to see the piece of silicon on its substrate, which eventually is connected on the motherboard. These are typically chip on board. Okay. So, these are typical daughter cards as we see, and these, as said before, these daughter cards onto the motherboard, that is how I am slowly building up the system. Okay. Started with a piece of silicon, level 0, coming out from the silicon wafer. Level 1, put it on the chip carrier, had the substrate, and finally, all these wire bonded the chip to the substrate, everything done, and the substrate also has these interconnections ready to be connected to the motherboard. That is where we stopped at level 1. Level 2, we went ahead and looked at motherboards. Okay. Now, we are trying to see that how do I then put these sub assemblies onto the motherboard to make the final assembly that will form the major part of the final system that we are going to sell in the market or that we can buy in the market. Clear? Just a side note here, you may also argue that in case especially for a pin grid array or a land grid array on which the CPU is resting, these are also removable. These can be attached on the motherboard and removed, okay, the removable part, correct. So, one can argue that well, this is this part, can I say that these packages are like daughter cards? Not necessarily, and you can say whatever you want. These are typically not, we do not call them daughter cards or circuit cards. Okay. These are packages specially designed to house a high performance piece of silicon or a high performance chip. Okay. All right. So, next thing is connectors. So, what are connectors? We all know what connectors are, we use it every day, but It is an electromechanical device providing a separable, keep in mind separable. It cannot be a permanent attach, I have connected it and that is it. No, I should be able to remove it. So, it is a separable interface between two electronic subsystems. See some examples of connectors. Okay. There are various types that are available. So, what is it supposed to do? Yes, it is supposed to connect two electrical systems, fine. Well, I can take two wires, strip off the insulation and then connect them, that is also a connector, a very crude one. So, how do I say what is a good connector, what is not a good connector? So, with minimal loss of power and signal integrity, very important. The electrical connection has to be very good. It cannot be a tarnished surface, there is a loss of signal and all that stuff. Many a times we see if we do not connect our projector to the CPU tower in our desktop, you will see that the display on the projector is is not great. And then sometimes say, okay, no, tighten the connector. And then when you tighten it, yeah, suddenly now you see the better colors, right. So, it does play a role, the signal integrity, the purity of the signal as well as the integrity of the signal that gets transmitted from subsystem 1 to subsystem 2 through this connector needs to be maintained very well. So, it plays a vital role not just in performance, but also in reliability. Why is it important? Because remember the word separable, this is removable, detachable. So, the connector should be designed so that it can be detached multiple times, right. So, the reliability, and so every time I attach and detach, I should not be losing performance, right. Now, so depending on what I want to do or what I am trying to do, these connectors can, the number of times you have to attach and detach during the life cycle of a product can be very variable. If I am talking about a display monitor and a desktop computer, probably that is very rarely would you remove. Okay, for the first time it is connected and then you work on the desktop. On the other hand, if you are at your desk and using your laptop and you want to use the laptop as a portable device when you go somewhere, but when you come back to your desk you want a larger screen. So, every time you have to connect this connector cable that will connect your laptop to the larger screen. So, that is an example where this removability, the number of times it is attached and detached is much higher, is high, correct. Think of another connector, USB connector. You are plugging in your USB device and plugging it out. If it is a memory stick, flash memory stick, you are doing it many times. And you cannot say that with every time the connector performance goes down, my signal integrity goes down or the surface is getting tarnished, you cannot do that. Okay. So, the functions and features, definitely it has to meet the functional criteria, which is current, the current has to flow, the connections the electrical connections has to be made, but there are several other functions and features as well. It has to maintain the temperature rating, okay. It cannot give rise, this connection should not lead to a hot spot where the temperature is very high, it cannot. Okay. Durability, which I was just talking about, the number of insertions and extractions, number of attachments and detachments. Okay. It should be able to withstand vibrations and shock depending on what you have put in. There will be some vibrations, we are going to talk about vibrations by the way when we talk about in the second half of the course when we talk about reliability. But vibrations is important. Vibrations can happen at multiple stages for a product. For example, if you talk about military applications, space applications, automotive electronics, there is a lot of movement and vibrations all the time, but your connector should be able to withstand. It should not, there is vibrations, so this connector has become loose and then it falls off. No, not allowed, right. During shipment, it can be, even if you are talking about a static product like a TV or a desktop computer or a server, during shipment it is going to be subjected to vibrations. Okay. So, it should be able to withstand vibrations. Even a desktop, even while it is working, you are going to have a fan inside, cooling fan. The fan gives rise to some vibrations, right. We try a lot to dampen it by having the right attachments and fixtures, but it is possible. Okay. The last thing is resistance to moisture ingress and corrosion. This is a very what should I say, one of the major causes of failure, or if not failure, degradation of the performance is over time there is moisture ingress, the surfaces gets, if there is moisture, then the surfaces react, there is corrosion that happens at these connector surfaces. So, all these actually degrade the performance. So, therefore, the surface material, the materials of this connector, especially on the surfaces where they mate, where the connection actually happens, has to be chosen very carefully, so that it is able to maintain both the performance and the reliability. It is able to maintain both performance and reliability. Okay. So, I have given some I have given some materials, but this is just a small subset. There are a variety of materials that are available. Okay. So, these are some connectors that you see inside a system, you will see a lot of them. But what are some of the connectors that we see more more often? See, the first one is a ribbon cable. If you open in many electrical and electronic systems, a ribbon cable is quite common. You see that. Okay. I think all of us have seen how it looks, how the connections are, all right. The round cable, especially for TVs, for microphones, and even the smaller ones, when the older ones before USB became very popular, the keyboard and the mouse, those connectors used to have these rounded connectors, round cable connectors. Okay. You also have connectors, for example, stereo the headphone jack, the mono stereo, these you will see those. Okay. These are round cable connectors. Then some of the more common ones, SCSI, SCSI, we have seen this kind of connectors before, and they are not very common these days. But again, as I said, even 10-15 years back, these were very common. If you have some of the older desktops, you will see these. Okay. So, there will be a female part, there is a male part, I am forgetting the number of pin counts, but there used to be large number of pin counts. Okay. Now, what happened was that made way to, not made way I would say, then, but there were also parallelly there was VGA connectors, right. And even today a lot of the computers, especially desktops and even some laptops, have VGA connections. Okay. If you have to connect a laptop to a projector, even a few years back, VGA used to be the standard. Okay. Now, slowly that is making way for HDMI, as you see over here, but even today there are many systems which have VGA. So, I always move around with a VGA to HDMI, HDMI to VGA connector, or basically an adapter, because my laptop is a new one. So, it is HDMI, it is slowly becoming default. There are some laptops, by the way, for example, my older one, which was a larger one from Dell, that has both HDMI as well as VGA, but the smaller ones these days typically have HDMI only. But the projectors have not the projectors have not been upgraded. Typically you do not replace a projector that often. So, therefore, many a times the projector connector, the connector is still a VGA. So, that is the reason I move around with HDMI to VGA adapter. All right. And USB and micro USB, these have become so common these days. USBs, any of your flash drives that we use are USB drives, USB 2.0, and micro USBs, which is most of our cell phones today are micro USB, right. It is USB 2.0 on one end, micro USB on the other. If you want to transfer files from your phone to your computer, or even as a charger, the charger pins are all now, most of them I would say are micro USB, most of the Android phones. Okay. Apple again uses its own connectors, that is one way, by the way. There is the other thing where you do not find a lot of standardization is the plug, the charging plug of your laptop. It is very different. On one hand it is a 3-pin plug, but what comes out is not the same. That is why a Dell charger, many people say, oh, I forgot my charger, can I borrow yours? Well, but how is your pin? Oh no, this is not going to work on mine. All right. Apple again is completely a different issue. So, the Apple chargers can work across Apple products, many of them, but for example, an Android phone charger with micro USB, you cannot use that to charge your iPhone. And of course, both all connectors are good, no question about that, but a lot of it sometimes is also business driven, because companies do make some money by sale of these accessories. Okay. So, if an Apple owner can go and buy an Android charger, then the Apple chargers are not going to get sold. Okay. So, there are all these business angles as well, same for the laptop chargers as well. So, they would like you to buy a charger which is specific to your laptop. Okay. All right. I hope I did not offend anybody by saying these. All right. The final thing is, okay, now I have these connectors. I have talked about connectors, which looks a little trivial, but you know there are lots of standards, especially these are all these need to be standardized a lot. Even though I talked about examples where it is not standardized, even though it can be, but a lot of these SCSI, HDMI, USB, these are standards, right, and a lot of years of efforts have gone into coming up with these connections. Okay. So, finally, it is the enclosure assembly. So, I have now the laptop, I have connectors, etc., etc. I have the circuit board, I have the daughter cards, I have the connectors. Maybe I will also have fans and all attached on the motherboard with a connector. Many a times it is just wires or it is a ribbon cable, but finally it goes into the assembly, the chassis. So, the final enclosure is the final housing for all systems and subsystems, and what are its functions? It gives the overall protection from adverse environment, okay. Protection of internal components, okay. You have to internally you have to put some kind of shields, etc., for EMI radiation, electromagnetic radiation. It should be amenable to field replacement, okay. So, I should be able to remove the chassis, replace any products and put it back. I should be able to, especially for desktops and all, which is configurable, I should be able to add what I want. There are many people who actually build their desktop bottoms up, it is possible to do that. Okay. There should be adequate airflow for efficient cooling. So, chassis design actually is important, especially we are going to talk about thermal design later, and it has a great impact on the airflow inside, both in terms of how much of airflow in terms of cubic feet per minute, sorry, CFM, or even the flow path. If you have a fan, cooling fan, you have to direct the flow towards the hot components. How do I do that? So, the chassis design is not so trivial. It is not just like an enclosure, you take a sheet metal, close it, so basically fold it, fold that sheet metal to your desired shape and just put it around the system. Okay, it has more to do with that. Then easy access to essential controls, ports, switches. So, for example, I mean if I have to plug in my USB drive, I should not have to open the chassis and attach it to the motherboard. The port, the connection port should be accessible from outside itself, easily accessible, all right. So, similarly for the Ethernet card, right, we saw this one. So, this piece of metal that you see actually is on the back side of your desktop, and this one is visible. This port where you plug in your Ethernet cable is right there. So, you do not have to really open the chassis to access this, right. So, the design of the chassis has to be like that, so that this comes right on the surface. Same for USB ports. If I have to plug in my USB port or my flash USB drive, or then I should be able to do this. If it is a memory card like this one, yeah, there also we have slots right now, correct. And earlier we used to have PCMCIe slots as well. Nowadays this is kind of becoming obsolete, we do not see that anymore. But what I am trying to say is these connectors have to be easily accessible, and which is what I am trying to show over here. Easy access to essential controls, switches, ports, connectors, and then indicators to indicate or alert in terms of functioning, malfunctioning, warning. So, for example, I will again go back to the previous picture over here. This Ethernet, as soon as it is plugged in, we sometimes see a green light over here. If the connection is not very good, we see a blinking yellow light, right. It gives you all these indicators. If your laptop is low on charge, you have a green light if it is fully charged, but then the lights can turn into orange or yellow if it is low on charge, right. So, these indicators are there. So, LEDs to indicate these, and these are just a couple of examples I mentioned. And finally, nothing to do with functionality, but an extremely important quality of an enclosure is aesthetics, looks, because this is what you finally see from outside. It has to look good. That increases the desirability. Why do you think people like Apple laptops so much? Because it looks so nice, it looks so sleek from outside, right. So, that is very important. So, different form factors depending on this, even the same product, I am showing desktops for example here, the same product, but if you look at the size and functionality and what is inside, you have different form factors, right. So, if you look at these towers, there are so many types. I have nowadays most computers are in this tower form factor, but I have used these kinds where actually this is your the base unit and the monitor actually sits on top. Okay, now these are not very common. Okay, and then depending on these are, so these are like what they were called ATX chassis, I believe at one point of time, these are different sizes. Okay, what is the material? Some of these are made of plastic, some of these are metallized, some of them are metals like magnesium is very popular, and so on and so forth. And as you can see, looks are important, they all look very nice. Okay. And which is the last slide that I am showing here, aesthetics, right. I talked about how looks do matter. Look at the two, and you should not be comparing them because the one on the left is a very old one. We used to use that at some point of time. That used to be quite the standard, this cream ABS plastic chassis. Even the behind part, which used to be metal, would also be color coded. Actually, at that point it looked good. I still feel this looks pretty sober, but compare that with the designs on the right. Think of this young crowd today, okay, the gaming systems, the gamers. So, if they have to choose, and again, by the way, it also depends on the population that you are talking about. If it is a young college going students or very young professionals, then they prefer a certain looks and aesthetics, okay, a very cool looking, funky looking stuff that attracts them, right. So, I for example remember there was once a laptop that Sony came out, Sony Vaio, very nice, and they came out with different color schemes, purple, green, I mean this, you know, this punk green, very bright light green, violet, silver, orange, several colors. And then you know what, they actually put some two connectors so that you can connect a strap, and you could connect it like a bag. This sling would come across your shoulder, and it looked exactly from outside like a lady's handbag. And apparently Sony probably did some market survey and saw that that design had some appeal for young women. They would like to carry their laptops in that manner, okay, and they came up with that. So, aesthetics do play a role. There is a lot of market research that goes on as to how your product is going to look, and let us admit that today when we go to buy a tablet or a cell phone or a smartphone, looks do bias us. We just do not go by the configuration inside. That is important, but I think we will all be lying if we say that we are completely, you know, insensitive, or we are not at all impacted by how the product looks. It does matter, aesthetics do matter, all right. So, that brings me to the end of this lecture. Again, some references over here, and that kind of wraps up our discussion on the final level of packaging, which is system integration. We are calling it third level packaging, some people may call it third and fourth level packaging, whatever it is, but At the end of second level packaging, we stopped with the motherboard with components and packages on top, and finally through today's lecture we converted that subsystem, if I may call it so, into a full system which is housed inside a final enclosure and ready to be sold to the customer. Okay? And so, we have therefore packaged our electronic product. Thank you very much, and from next lecture onwards we are going to talk about the reliability aspects starting with thermal management. Thank you very much. Bye.